Find the length of segment AB. We can see that point A is at the point 1, -4, and that B is at the point 4, 4. Now what we can do to help us find this segment is to consider a right triangle. If I create a right triangle here using one of the sides of the right triangle as the horizontal length and one of the sides of the right triangle as the vertical length, we see we have our right angle right there, then segment AB becomes our hypotenuse, also known as C. The Pythagorean theorem states that the sum of the squares of the legs is equal to the square of the hypotenuse. So if we consider this point where we have our right angle at the point 4, -4, we can calculate the length of each of those legs of the right triangle. The distance from 1 to 4, how many units is that? That would be 3 units here. And the vertical distance goes from 4 to -4. How many units is that? 8. So we can apply the Pythagorean theorem here, which is the sum of the squares of the legs is equal to the square of the hypotenuse. By substituting in our values, we know that 3 squared plus 8 squared is going to equal C squared. So 9 plus 64 equals C squared, which means C squared will equal 73, and then we must take the square root of each side. So C is exactly equal to the square root of 73, which is approximately 8.54 units. Now let's calculate the distance in general terms. So let's say we don't know the actual coordinates of A, and we call that x1, y1. And the coordinates of B would be x2, y2. Now if I want to find the horizontal length and the vertical length and plug that into the Pythagorean theorem, we know that this ordered pair right here, in general terms, would have the same x-coordinate as that second point of x2, and it would have the same y-coordinate as our first ordered pair of y1. So if I'm finding the horizontal distance, I would be subtracting x2 minus x1. So we're going to say x2 minus x1, and then we square it because we know in the Pythagorean theorem that it's a squared, and then plus b squared. So if we did the same thing with our vertical distance here, this would become y2 minus y1 squared. And then we know that that equals the length or distance between A and B. So I'll call that D squared. Now, if I want to solve for D, which is the distance between points A and B, or as we can say AB, which is the length of segment AB, we would just need to square root each side. Therefore, we get our general distance formula, which is the square root of x2 minus x1 squared plus y2 minus y1 squared. Okay, so now let's do an example. We want to find the distance between these pair of points. The distance between these 2 points is also the length of the segment that joins them, where these points would be your endpoints. We want to round our answers to the nearest hundredth. So we're going to use our distance formula, which, as we just learned, is x2 minus x1 squared plus y2 minus y1 squared. And I'm going to actually label each of these coordinates. So I'm going to call this x1, y1, and this x2, y2. It does not matter which one you actually call x1, y1 or x2, y2 as long as it's consistent within the ordered pair. Meaning, if this is x1, this must be y1, not y2. So now we're just going to substitute in our values. So, substituting in, just be careful of those minus signs, those negatives. We would get 4 minus 2 squared plus -1 minus 3 squared. So, simplifying, we would get 2 squared plus -4 squared, which equals 4 plus 16. And that's the square root of 20. And if we do as our directions say, which is round to the nearest hundredth, that's to 2 decimal places, we know the square root of 20 is approximately 4.47.